Students, now we are going to discuss the question, derive the expression for pressure, volume, work, 3 into V work. This is also important question for 2 marks, that is also called as the derivation for pressure, volume type of work. So for that purpose, we are taking the diagram. Explanation of diagram is very important. So this is our cylinder, this is the bottom, this is the top portion, and piston is present here. Okay, you know that piston, when you are going to apply the pressure on the pump which is used for filling the air in the bicycle, so taken upward, that is the piston, we are pushing it downward, that is called as the piston will move upward and downward. So initially our cylinder is having the pressure P and its volume is V1. Okay, now which will allow to expand the gas. As gas expand, this piston will move in a upward direction. At the same time, there is applying pressure P external is opposing that piston to move in upward direction. So pressure is applied upward direction and external pressure P external is applied downward direction. Pehla volume V1, second volume V2. Okay. For that purpose, after considering this diagram, we are explaining it. Consider a certain amount of gas at constant pressure P is enclosed in a cylinder fitted with frictionless rigid movable piston of area A. This is our cylinder which is enclosed by means of a gas having the pressure P, and the piston is considered to be frictionless and rigid and movable with area of cross section A. Okay, after that what is happening? Let the volume of the gas V1 at temperature T. When cylinder is having the pressure, gas is filled, it is having the pressure P, but it is having the volume V1 and its temperature is T. Okay, now for solving purpose, for this purpose we are taking on expansion of the force exerted by a gas. Whenever the gas is allowed it to expand, gas in the cylinder, gas is allowed it to expand, by expansion there is a exertion of the force by a gas equal to the area of piston multiplied by the pressure. Means gas is allowed it to expand, the force exerted by gas is equal to the area of piston multiplied by the pressure. Clear? The pressure is equal to the magnitude and opposite in sign to external atmospheric pressure, hence it is negative. You know that pressure is, there are two types of pressure in the figure. First is the cylinder is having the piston at position this, it is having the gas, that is called as the pressure P. At the same time, when it is expand, it move in upward direction. At the same time, the air outside the cylinder will apply the pressure in a downward direction. Means gas expand and it apply the pressure in upward direction, but the air, it apply the pressure in a downward direction. Means this pressure is equal to the, this pressure is equal to magnitude and opposite in sign to external atmospheric pressure, hence it is negative. It's a negative phenomena because the pressure, when you are considering, they are having the magnitude equal to the pressure, only the direction is negative. Therefore, P external is having negative sign. It's a negative phenomena. That's why it is not considered as a P external, but it is considered as a minus P external. That is negative point. Clear? So here pressure we are applying by expansion of the gas, gas is allowed it to expand, that's why piston is moving upward direction. Therefore pressure applied by the opposing air and the pressure applied by the piston are same, but their magnitude is change. When it move downward, P external will be positive, but when it move upward, it working against that pressure, that's why its value is negative. Therefore we have taken minus P external. Clear? After that, what is the formula of force? Force is equal to, it is the product of pressure into displacement. So F is equal to minus P external into A. This is our important equation number 1. So this equation, when you are considering, the amount of work done is equal to the product of force and displacement. We have derived the derivation W is equal to minus P external into A. But what is the formula for the work done? Work done is equal to force into displacement. This is our equation number 2. When you are observing, the value of W is equal to F into D. So from equation 1 and 2, this equation number 2 become W is equal to F into D. But what is the value of F? F is equal to minus P external into A. Placing this value in equation number 2, so W is equal to, what is the value of F? Minus P external into A. So W is equal to minus P external into A into D as it is. It results in the equation number 3. So W is equal to minus P external into A into D. This is our equation number 3. Clear? Means W is equal to minus P external into A, equation number 1. But W is equal to F into D. Now placing the value of F from equation 1 into equation number 2, W is equal to, what is the value of F? Minus P external into A and D as it is. So W is equal to minus P external into A into D. It is equation number 3. Clear? Now we are moving to the volume change is equal to the product of area and distance it move. So what do you mean by volume change? Volume change is equal to the product of area and distance it move. Delta V is equal to A into D. So this is the mathematical equation for change in the volume. Delta V is equal to A into D. This is our equation number 4. Before this, we have taken the equation number 3. What is equation number 3? W is equal to minus P external into A into D. But now A into D, we are getting the value A into D is equal to delta V. Therefore, equation become W is equal to minus P external as it is, and A into D is now replaced by delta V. So W is equal to minus P external into delta V means V2 minus V1. Delta P means P2 minus P1. So W is equal to minus P external into V2 minus V1. This is our main equation, equation number 5. So this derivation we have taken for expansion of the gas. You know that gas is allowed it to expand, pistons move in a upward direction. So work done is negative. That's why W is equal to minus P external into delta V means minus P external into V2 minus V1. So same derivation we can also apply by changing the conditions. When you are taken the piston, gas is allowed it to expand, it move upward direction. Now gas is allowed it to compress, then piston will move in a downward direction. As piston move downward direction, work done will be same, but direction will be changed. Here we have taken P external, but that is minus P external. Now this minus P external is replaced by P external because for compression there is a opposite phenomena. It is a positive phenomena. That's why minus P external is replaced by P external. So W is equal to P external into V2 minus V1. So that is the expression we have derived for expression for pressure volume type of work. For expansion of gas, W is equal to minus P external into V2 minus V1. But opposite to this, for compression of a gas, W is equal to P external into V2 minus V1. This is the derivation we have derived. Now, this derivation we are going to explain. आज हम लोगों को देखना है कि प्रेशर वॉल्यूम टाइप का वर्क जो रहता है उसका डेरिवेशन डिराइव करना है. इसके लिए हमने डायग्राम कंसीडर किया है. इस डायग्राम में एक सिलेंडर लिया है, सिलेंडर में गैस एनक्लोज है, उसका प्रेशर है P. पहली पोजीशन जो है पिस्टन की ये है, यहाँ पे वो है, उसका वॉल्यूम है V1. हमको उसका एक्सपांशन करना है, इसलिए गैस जब एक्सपांड होगा तो ये पिस्टन को कहाँ धकेलेगा? ऊपर धकेलेगा. ये यहाँ से यहाँ तक आया. पहला वॉल्यूम V1 था, अब दूसरा वॉल्यूम क्या हो गया? V2 हो गया. तो उसने कितना डिस्टेंस ट्रेवल किया? ये डिस्टेंस ट्रेवल किया, ये यानी ये कितना है? D. जब हम इसको प्रेशर का क्राइटेरिया अप्लाई करते हैं, तो जो प्रेशर है वो प्रेशर दोनों तरफ से सेम रहता है। ए पिस्टन अपवर्ड जा रहा है, उसको कौन अपोज कर रहा है? एयर का प्रेशर। दोनों का प्रेशर सेम है, पर ये निगेटिव फिनोमिना है, इसीलिए इस प्रेशर को हमने क्या लिया है? माइनस पी एक्सटर्नल। हो गया। उसके बाद फोर्स का फॉर्मूला क्या है? W इज इक्वल टू माइनस पी एक्सटर्नल इंटू ए, बिकॉज हमने यहाँ पे फोर्स अप्लाई किया है, गैस को एक्सपांड किया। गैस को एक्सपांड करने के बाद जो फोर्स है उसके वजह से पिस्टन अपवर्ड गया। इसका मतलब उसने डिस्टेंस क्या कवर किया है? d। इसका मतलब फोर्स जो है, फोर्स इज द प्रोडक्ट माइनस पी एक्सटर्नल इंटू एरिया। हो गया। उसके बाद वर्क डन का क्या फॉर्मूला है? वर्क डन इज द प्रोडक्ट ऑफ फोर्स इंटू डिस्प्लेसमेंट, W इज इक्वल टू एफ इंटू डी। हो गया। अब जो W है वो निकालने के लिए अपने पास फोर्स का पहले इक्वेशन का वैल्यू है, क्या वैल्यू है F का? माइनस पी एक्सटर्नल इंटू ए। उसको हम इक्वेशन नंबर 2 में प्लेस कर रहे हैं। W इज इक्वल टू फोर्स इंटू डिस्प्लेसमेंट, व्हाट इज द वैल्यू ऑफ F? W इज इक्वल टू माइनस पी एक्सटर्नल इंटू ए, डी एज इट इज, डी जैसे का वैसा। F की वैल्यू क्या है? माइनस पी एक्सटर्नल इंटू ए। सो W इज इक्वल टू माइनस पी एक्सटर्नल इंटू ए इंटू डी। ये हो गया इक्वेशन नंबर 3। उसके बाद वॉल्यूम चेंज हम कैसे निकालते हैं? वॉल्यूम चेंज का मतलब क्या है? वॉल्यूम चेंज इज इक्वल टू द प्रोडक्ट ऑफ एरिया एंड डिस्टेंस इट मूव। इसका मतलब डेल्टा V इज इक्वल टू ए इंटू डी। सो जो इक्वेशन नंबर 3 था, क्या था इक्वेशन नंबर 3? इक्वेशन नंबर 3 था W इज इक्वल टू माइनस पी एक्सटर्नल इंटू ए इंटू डी। यहाँ पे ए इंटू डी टर्म है, वैसी टर्म डेल्टा V का मतलब क्या होता है? ए इंटू डी। इसका मतलब इक्वेशन नंबर 3 क्या होगा? W इज इक्वल टू माइनस पी एक्सटर्नल जैसा क्या वैसा रहेगा, और ए इंटू डी रहेगा, उसकी जगह क्या आ जाएगा? डेल्टा V। सो W इज इक्वल टू माइनस पी एक्सटर्नल इंटू डेल्टा V। डेल्टा V का मतलब क्या होता है? फाइनल वॉल्यूम माइनस इनिशियल वॉल्यूम, V2 माइनस V1। सो फाइनल इक्वेशन क्या बन गया? W इज इक्वल टू माइनस पी एक्सटर्नल इंटू V2 माइनस V1। ये एक्सप्रेशन किस लिए आ गया है? क्या लिया हमने? कॉम्प्रेशन एक्सपांशन लिया था गैस का। गैस सिलेंडर में फिट था, उसको एक्सपांड किया तो सिलेंडर का पिस्टन ऊपर गया। इसका मतलब क्या था? एक्सपांशन। W इज इक्वल टू माइनस पी एक्सटर्नल इंटू V2 माइनस V1, और W इज इक्वल टू माइनस पी एक्सटर्नल इंटू डेल्टा V। अब उसकी अपोजिट फिनोमिना ली हमने फॉर कॉम्प्रेशन ऑफ गैस। कॉम्प्रेशन होगा तो क्या होगा? पिस्टन डाउनवर्ड आएगा। अब जब एक्सपांशन था तो पिस्टन अपवर्ड गया, W कैसे आ गया? निगेटिव आ गया, बिकॉज हमने P एक्सटर्नल को कैसे लिया था? निगेटिव। पर यहाँ पे कॉम्प्रेशन है तो P एक्सटर्नल कैसे रहेगा? पॉजिटिव। तो W इज इक्वल टू P एक्सटर्नल इंटू V2 माइनस V1। So this is the very important derivation we have discussed today. It is asked for the 2 marks. So next part we will see in next video. So now we'll stop here.